Hello interwebs, welcome to Let's Fix Computers. Today we're going to be talking about 3D printers. Now I've never used a 3D printer before. I've never even seen one in real life that's actually, working and stuff like that. But recently I've taken quite an interest in the idea of having one because you can use them for building all kinds of cool small parts. Like replacement parts for something that's broken, unique fittings for things, and other cool stuff like, figurines and models and that kind of thing. And so when Creality reached out to me and said, hey, do you want to look at some of our stuff? They sent me their Ender 5 S1 3D printer as well as their Sonic Pad Clipper control computer thingy as well. So as someone who's never used a 3D printer, I wanted to do a review of this product and actually explain to people who are in the same boat as me, how do you get started with a 3D printer? How do you set one up? How do you work it? How do you bring something from the screen into physical reality with it? So let's sit back and see if I can figure out how to set this thing up and make it do stuff. So the first thing I had to do is actually assemble this thing. The Ender 5 S1 came in a surprisingly small box and it was impressively well packaged. Everything was very tightly packed with foam blocking between everything, so it didn't rattle around or anything at all. I was actually a little bit intimidated when I opened it up and saw how thick the manual was and that there were 3 layers to this box, but it is actually a lot simpler than it looks. And it took me a lot less time to build than I thought as well. Most of the complicated stuff is already pre-assembled, and a lot of it is just a couple of struts and bolts you've got to put in. I do recommend going across all of the bolts with a screwdriver to make sure that they're all nice and tight, because some of them had come loose during shipping. And I think this is to be expected. I spoke to a friend beforehand for this project, and he advised me to check the tightness of all the screws beforehand, and he was right on the money with that. However, following the instructions in the manual, I was very easily able to get this guy assembled and set up on a bench. Now we've got the printer assembled, we need to make sure that the print bed on it, or the build plate, is perfectly level. Because obviously, if the build plate is sloped, when the print head moves across perfectly horizontally, it's going to have a slope, and it's not going to make a level structure. So, as the name suggests, we have to make sure it's leveled. Now, the manual that the printer came with didn't actually explain how to do this. It actually just had a note saying words to the effect of "see electronic note on how to level it." And this seemed a little bit unnecessary to me because the process of bed leveling isn't super complicated, so I feel like that should have been in the manual. However, Creality do have videos online explaining how to do this that were very helpful. So I followed their online videos to achieve this. The gist of leveling the printer is to go into the settings and select leveling mode, and it will automatically home the printer head into the middle, and it will detect where it thinks the absolute bottom of the Z-travel is. So that is to say, when the nozzle touches the bed. Then what we do is we put a sheet of paper between the bed and the nozzle, and we adjust the height adjustment screws on the bed until that paper just starts catching in the gap. Then you back off slightly so it moves freely again. Then we go to each of the corners in turn and repeat this process. And this means that we should end up with a bed that is perfectly level in relation to the nozzle of the printer. Once we've done this, we can run the Ender 5's auto-leveling system, and this will probe across the print bed and check for any other irregularities in the print bed, such as spots that are slightly higher than others and so on, because this is not like a perfect engineer's table flat surface. And it will calibrate itself so it knows which areas are fractions of a millimeter higher than others. And this again allows it to make sure that it's printing perfectly level when it's actually in operation. One bit of advice I would say is, if in doubt, I would back off a little bit further, because if you have your Z-axis, that's the height, slightly too far away from the print bed, then the print will come out all wonky. However, if you have it too low, then the nozzle will crash into the print bed and mark your build mat. Ask me how I know. That's why there's a mark on the build mat now. When I actually spoke to some other people about this, they all laughed at me and said, ha ha ha, everyone does that on their first printer. So yeah, these build mats are replaceable, so it's not a big deal if this happens, and certainly I didn't seem to do any meaningful damage by being a little bit too close the first time round. The Creality Sonic pad that I also have can do the bed leveling to a more detailed amount, and it can show more details about the bed, and it has a visual graph showing you imperfections and things like that. However, I ran the leveling both with and without the Sonic pad in order to see what the benefits of both were. And doing it without is more or less exactly the same process, but it is using less points of accuracy to check the bed. So adding in the Sonic pad gives you a more accurate print bed. So now it's time to actually print something off. I had a look at the flash drive that came with the printer, and I found 2 example files on it. There was one called Rabbit and one called Boat. And the Boat model is one that I've seen before in other videos, so I think it's a very well-known test bench for 3D printers. And the Rabbit had a very short print time on it, so I started printing off the Rabbit just to see what would happen. And just as promised, we printed off a rabbit. Now, as I previously mentioned, for this run, I had the leveling set slightly too low, so the bottom layer for the rabbit didn't come out very well, but once it started rising up, the rest of the model came out just fine. The actual black build mat sticks magnetically onto the build plate and is removable. The polycarbonate one that comes with the Ender 5 tends to be a bit aggressive in sticking to the part. Now, this can be useful to stop parts from coming astray during the start point of the print. However, it does mean that it's quite a lot of effort to actually remove your part afterwards. And on all of the test prints that I did, I had to fight quite a lot to scrape them off of the build mat. I didn't break anything doing this, but I can certainly see why a lot of people tend to not favour polycarbonate mats. I could definitely see myself trying some other possible surfaces like glass or plastic and so on. However, the polycarbonate plate does seem to function just fine. The next print I did was the Boat, and for this particular print I'd connected up the Sonic pad at this point, which I'll talk more about in a moment. And the Sonic pad was able to control a webcam to take an automatic time-lapse of this print. Now, the particular settings I had dialed in caused it to move the print head to the corner before taking each picture of the time-lapse. And this actually, it didn't ruin the print, but it caused it to go very strandy because the print head was moving way out of the way at the end of each layer of the print. So as you can see in this time-lapse, there was a lot of stranding building up. However, the print still came out just fine. I just had to cut and I just had to use a knife just to cut off the strandy bits. Now, the parts themselves are actually impressively strong. I decided to put these to the test because, you know, you can always make more of them. So for this boat here, it's got this little chimney on top, and I thought, oh, surely that'll snap off if I try, right? Let's find out. So here we go. I'm not kidding, I'm trying here. Oof. There we go. I hope that came across how much effort I had to exert to snap that off. That was not easy. That's marked my finger trying to do that. So, impressively strong. I was very impressed at how tough these things actually are. Now, not all 3D prints will have this kind of durability. This boat is very meticulously designed. However, just to prove a point, if it's well designed, that's the kind of strength you can actually expect from these things. So, depending on how you design the part, you can make something that is impressively difficult to break. So very impressive all around there. So these two test prints I did, the Rabbit and the Boat, they came supplied on a flash drive, which was actually an SD card in a reader. And you could take the SD card out, slot it into the side of the printer, and then on the printer's built-in touchscreen, you then go print and you select your file and you click print. And that's it. It starts doing the thing. And that touchscreen menu is fairly straightforward to use, but there's not really a huge number of options that we can actually drill into here. And this is where the Sonic Pad comes in. Now, the Sonic Pad is fundamentally just a small tablet that is running firmware called Clipper. And Clipper is 3D printing firmware that provides more advanced control of the printer. Because a device running Clipper, so either a Sonic Pad or your own custom built device, so it could be a small computer or it could be a Raspberry Pi or whatever, because this has a lot more processing power than the built-in control board for the printer, it can do many, many more calculations at a time. At a basic level, you have further access to controls on the printer. You can control multiple printers, and you can have a bigger screen giving you a more verbose output of the status of the printer. But at a more advanced level, you can even hook up G-sensor probes that actually detect the shock movements of the print head. And by calculating acceleration and deceleration, Clipper can actually increase the speed of the printer and account for vibrations and acceleration and slowdown and so on. So it can effectively overclock your 3D printer to achieve higher print speeds and finer control over things. Other features about it that I really liked are the fact that you can plug a webcam into the Sonic Pad and it will automatically create time-lapse videos of your prints for you, which is super cool. And there is also a web interface that allows you to manage the printer remotely, which is particularly useful if you want to put the printer in a workshop somewhere while you sit in comfort in front of your computer. Because so far, one of the things that I've really found is that I really want to be able to keep half an eye on the printer while it's operating. Especially if I'm doing a print where I'm not sure if it's going to come out well or not. I kind of want to know as soon as I can if there's a problem, so I don't waste a whole load of filament on a failed print. Two of the criticisms that I did immediately have with the Sonic Pad are firstly that while it can control multiple printers that are connected to its multiple USB ports, the first printer that you're using must be connected to USB port number 1, which is on the side of the pad, not on the back. So even though we've got this nice pad with a kickstand on it, so it sits in front of your printer nicely, you must have the actual printer cable connecting to the side of it. So it's kind of difficult to have this thing set out in a nice cable tidied way without having a USB lead sticking out the side of it. And in addition to that, it doesn't really have any kind of structure to like bolt it to the side of the 3D printer or anything like that. And I suppose the idea is it sits on the desk, but this feels like something you would want to bolt onto the side of your printer, quite frankly. So I'd imagine that I can 3D print a bracket that will do this, but I'm just sort of surprised that it doesn't have this by itself, because this seems like an obvious thing you'd want to be able to do. The other big fail that I had with this, and there's probably a technical reason behind this, but when I did the auto leveling with the Sonic Pad, it actually missed the auto level and bumped the print bed into the nozzle. And the reasoning behind this was that the Z-axis sensor is on the bottom of the print head, and it's slightly offset to the left. And it seems like the Sonic Pad was expecting it to be centered. And what happened was the Sonic Pad moved the print head all the way over to the far left side of the print bed. And when it started bringing the print head up, the sensor missed the side of the print bed. And so then it crashed into the nozzle. So this presumably is down to this particular configuration, the S1 configuration. I'm guessing that the Sonic Pad was expecting that sensor to be somewhere else or had just not been set up for that. But Creality Sonic Pad, Creality printer, I have a suspicion that these two devices were not tested with each other, and considering they're both made by the same people, that kind of feels like an oversight to me. I avoided this by then just moving the build mat across slightly. So when it was offset, it then sorted itself out. And once it had auto-leveled, I then moved the mat back again. But still, I feel like there are some improvements that can be made here. Okay, so we've printed some sample models, but let's try doing something that's a bit more interesting now. So we want to firstly get hold of something to print. So one place you can go to for this would be a website like Thingiverse, which is a website where people upload stuff that is 3D printable. And so I jumped on Thingiverse and had a browse around. I was looking for figurines or something, a good demonstration that I could do. And I found a Fluttershy model, which I thought, oh, this will be a good figurine. I'll download this. So I've downloaded this and I've opened it in Creality Print, which is called slicing software. And what it means by that is we've got a 3D model and we need to print this in layers or slices. So slicing software converts a 3D model into a set of instructions that the 3D printer can use to recreate it. So it slices it into layers and says, move in this pattern at this speed, extruding this amount of plastic, go to next layer. And that outputs what's called G-code, which is what we print. So the model that I've downloaded from Thingiverse is an STL file. That's stereolithography. And it's basically a very simple 3D model format. And a lot of 3D modeling software, so, Blender or probably AutoCAD and stuff like that, can all export as an STL. And so we end up with this 3D model here. So I can spin this around and look at it, and we can see a preview of what it is we're going to print. And Creality Print is going to convert this into G-code, which is something that the printer can understand. But there are a few problems that we need to address with this first. If I go to Support in the top right here, what this is going to do is it's going to highlight sections that are illegal, so to speak. So these red highlights that we're seeing here, the red highlights show areas that the 3D printer cannot do. So let's take the tail, for example, here. The tail is floating in mid-air. Now, a 3D printer, it can't put something in mid-air. It has to have something to lay the plastic on. So straight away, this isn't going to work, which is why it's got a red highlight under it. And you can see we've got little red highlights all over the model, here, there, and everywhere, for areas that the 3D printer cannot work with. So how do you fix this? Well, you have to create supports. So what I'll do is if I click the automatic support option here, Creality Print will automatically create these little pillars that create supports. So by building this pillar of plastic up to that point, it provides a base that will then be able to print onto. However, I didn't really like this style of support. And I was told that this doesn't really work particularly well. And everyone I spoke to said, you want to use Cura, which is an open source slicing software. Now that's actually been bought out by Ultimaker now, but it's still open source. So I wanted to show you Creality Print because this is what Creality offer. However, to go any further, I'm immediately going to move to Cura because it's a much more powerful slicing system. So let's switch to Cura. So now we're in Cura instead, we have a lot more options available to us. Cura overall is better documented in a much more powerful program. Creality Print can work, but Cura, after very quick testing, I found is significantly more powerful. And it has these support types called tree supports. So what I'm going to do now is I'm going to hit the slice button and it will calculate the slicing. And so as you can see, with Cura's tree method, the support looks a lot more realistic now. What it's going to do is build a very thin wall around the areas that need support and build a structure up to those points. And because this isn't just a spindly pillar, the support itself is significantly stronger and less likely to fail. So I found this to be a lot more realistic and plausible for something that would actually work and be capable of reaching the areas that it needed to and getting to all of these complicated spots like the back of the main here without failing. So this I found to be more useful. And now we're in a preview, you can see that if we drill right in, it's actually calculated the layers of the model. So you can see right down to the little tubes of plastic that it's actually going to lay. And we can preview this on a per layer basis. If I drag this slider down, you can see the actual structure it's going to build, including the infill in the middle, which is the internal structure that gives it some rigidity without just filling it with plastic. And we can adjust how much the infill density is. You could make that great or less than to create a trade-off of strength and plastic usage versus using less plastic and speeding up the print time. So for this particular print at this size, this model is going to stand about 10 centimeters tall. But I can also scale this down. If I go back to prepare, I can scale that down. If we select the model and change the scale to say I want it to be, I don't know, 6 centimeters high, so 60 millimeters. There we go. So 60 millimeters, slice it. And now we have the same model, but it's 6 centimeters tall. And now that's going to print in 2 hours and 20 minutes instead of 6 hours. So you can see by adjusting the settings, you can trade off size versus build time. With my experimentation, I found that there was a trade-off of the size goes up slowly and then it ramps up. The size to build time. So, and if you try dialing in different sizes to the model, you might find that there's a sweet spot whereby making it, say, only 10 millimeters lower, you can save like an hour of build time, for example. And down in the bottom right here, you can see that it's going to take 2 hours and 20 minutes and use 15 grams of filament. And you can dial into Cura what your estimated filament cost is. A quick glance on Amazon says that a kilogram of filament is about £20. So I dialed in £20 for a kilogram. So Cura can now tell me that it will cost me about 30 pence to print this model, which is pretty good going, all things considered. So now I can save this to disk and I'll end up with a G-code file, which I can now put onto the Sonic pad and print. So let's go ahead and print this off. So our print is now done, and what I need to do now is I need to break away the support structure. So the support structure is extremely fragile and will literally just break off in your hands. You need to be a little bit careful not to damage the model doing this, but as we saw with the boat, the model is a lot stronger than it looks because it actually has infill to it, giving it structure and rigidity. So we can just very carefully break away and snap away all of this support until we're left with a clean model afterwards. And this particular model, it came out pretty good. It's got a couple of sharp edges on it here and there, but with a small needle file I could probably smooth this off. So I'm fairly happy with this result because now I've downloaded a file off the internet and then printed it. So I could do this for anything else I could find on Thingiverse or any other website. So there's 2 more projects that I want to do now on my 3D printing adventure. The first one is to try exporting a Blender model and printing that, because that means I can now pose my own models. And the other one that I'm going to try doing is actually making something from scratch, which would demonstrate my ability to create a part as I require it or as I want to design it. So now I'm in Blender, what I have here is a full 3D rigged model. So unlike the STL file that we had for the Fluttershy model, this is actually a rigged puppet with an armature that can be moved and posed. So with this one, I can enter pose mode and I can start adjusting this into whatever pose that I like. So I could just dial in something here and say, okay, well I want to make it so this character is standing in a casual pose per se. So let's just try adjusting this model to a standing pose. There we go. Now before I export this, I need to delete anything from the file that I don't want to export. So I would recommend saving this as a copy of the source Blender file and then doing your export, because you need to delete anything that is not going out into the STL file. Just having it hidden isn't good enough. So from this point now, I can go File, Export, and I can export it as an STL. And now we have our Blender export in Cura. So there are a few things to note here, is that I haven't done a lot of optimization to this model to prepare it for 3D printing. So Cura is highlighting a lot of internal surfaces and single pixel thick surfaces within the model that for the 3D model are completely fine, but it's highlighting them being like, yeah, that's not going to print. But this is fine, this is okay. You can also see that we've got a lot of red highlighting for, once again, stuff that can't be done. We've got a tail that is floating in midair as well. And in addition to that, we need to make sure we pay attention to the size here. So Cura has automatically scaled the model up significantly. I haven't quite figured out exactly how to scale the units when exporting from Blender, but because we're dealing with what is effectively a vector file, you can scale up and down without any meaningful loss. So I'm going to put in, say, 10 centimeters tall for this. So let's make that 100 millimeters tall. And then once again, I'm going to go ahead and give it some support. So let's turn on supports. And I want to use the tree support. And I only want it to place supports from the build plate, because I don't want anything supporting out from the model, because that might damage the result of the model. So as you can see, this one's going to need a lot of support. And once again, there are ways to optimize this. We could print the model in several different pieces that would require less support and then assemble it afterwards. We can put in support blockers to certain areas that probably don't need supports, like just under the ear here. We could probably not build that support and it'll be fine. And in addition to that, we could just print the entire model laying on its back, which changes the direction of the grain in the model, but again, would give it a much easier time. However, I want to challenge the printer. I want to see what can be done and what happens when you just throw something difficult at it. So I'm going to go ahead and just save this and print it. So let's just YOLO this and see what comes out. So for this model, I opted to make it 90 millimeters tall, because I found that, as I alluded to earlier on, taking it from 10 centimeters down to 9 centimeters took an hour off of the print time. So that's like a quarter of the print time saved by making it 10 millimeters shorter, or like 10% shorter. So I made it a little bit shorter, and then it took me about half an hour to slowly extract it from all of the support. And I had to go a little bit careful, because there are some delicate parts on this model. A few bits didn't come out. The tail, the tip of the tail went sideways during the print, and I accidentally snapped off 2 of the fingers while removing the supports. But these fingers are like maybe a millimeter wide, probably less than. So I was impressed that they actually printed at all. All in all, the model actually came out surprisingly well. There are lots of like little edges on this and little details that I thought were going to get completely lost in the print, but actually came out fairly well. I wouldn't say it's a work of art by any stretch of the imagination, but for something that was completely unoptimized for 3D printing, I thought it was a pretty good start. There are also a couple of just little blobs and just sticky outy bits over this model, and also the Fluttershy model. And I believe that this is caused by the power interrupt feature of 3D printers, which I've heard tends to make these little blobs because it adds like a little hesitation in here and there or something like that. So I'm going to try turning that off for future prints to see what happens and see if that helps things. However, again, I'm fairly happy with that because now that means that I can take a Blender model and I can pose it into any pose that I want and do repeated prints. So if you have the Blender model for a character that you like, you can do as many figurines of that as you like in all kinds of different poses. This could be really good if you have a Blender model for like a miniature that you use for, say, a tabletop game like Dungeons and Dragons or Pathfinder or something like that. You could have a couple of little minifigures like for a casual pose and a fighting pose, and you could swap them out on the board at your will. And you can print as many off of them as you like and just have a completely custom character. And I think that's really cool. Right, so let's do that aforementioned making specialist parts from scratch and prototype bits and that kind of thing. I want to make something from scratch in Blender and print it on my Creality Ender 5. So, the thing that I've chosen for this, I'm going to do something really simple. I'm going to make a GPU anti-sag bracket for one of my demo PCs. So this is going to be pretty simple. I'm just going to make what is fundamentally just a rectangle. But to actually personalize it a bit, I'm going to put my logo on it. So let's go into Blender here where I've just made a new file. And I'm going to start off just by deleting everything that's already in there. So we've got just an empty slate. So I have my logo available as an SVG, a scalable vector graphic, which is something that I can drop directly into Blender. So let's import that. So here's my logo, and now what I'm going to do is I'm going to build this up as a model. So I'm going to add some thickness to it and put some blocks around it so we have something that actually has a shape. There we go. Behold, a rough as guts model. So let's export this as an STL and then put it into the slicer. Right, here's our model. Now the main bit that I care about now is the actual print size of this. So the computer that I'm going to put it in already had a height adjustable graphics card stand in it. So I measured that with some calipers and found that it was set to 77 millimeters. So what I can do in this now is I can go to scale and I can set the long edge to be 77 millimeters long. So now this is going to come out at exactly the correct size to support the graphics card that's in there. It's not going to be adjustable in height. However, that's not an issue because if I change the graphics card, I could just print off another one. Obviously, there's probably designs out there that are adjustable, but for the sake of demonstration, this will do just fine. So there's no illegal edges on this because we're printing flat, so we don't need any kind of supports. So now I can just go ahead and hit slice. And in the preview, you can see how exactly it's going to build it up from scratch. It's going to do a bottom plate, then it's going to fill in at 20%, do a top plate on it, and then build up the logo. And this is going to use 6 grams of spool and cost approximately 13 pence and take 40 minutes to print. So we'll save that to disk, put it in the printer, and off we go. And here's my finished part. So the logo has a couple of smudgy bits on it. That little bit of black is because I actually changed the filament before printing this. I had the black filament in there and I changed it to white. So there was just a little bit of smudge on the end of the nozzle that I needed to clean beforehand. And that just came off when it was doing this little detail bit. So these little like smudgy edges that you can see on there, I think these would be cleaned up if, again, I optimized the model a bit more. I don't know much about optimizing for 3D printing, but there are obviously certain edges and shapes that you should try to avoid. But that will come in with practice. But broadly speaking, that's it. That's something I made from scratch. So that can now just go into a computer and prop up a graphics card. So now we've printed off sample models, we've downloaded a model from the internet, and we've made our own models and printed them off on our new 3D printer. So we can now expand on this and practice to create all manner of different things. From what I've found, getting started with a 3D printer like the Creality is really easy to do. It's much simpler than I expected to be. Likewise, once I printed off a couple of models, just very casually switching to a different filament to change colors was very simple and straightforward as well. And when I started looking around on the internet, I saw a complete spectrum of different colored filaments with different effects that really just I've only got black and white right now, but there's lots of wacky colors out there and different light effects where they look silky or they look wooden, they look metallic, and really cool stuff that I'm really excited to start buying and experimenting with. So getting started is very easy. Mastering it is a bit harder. As you saw with my models, all of them have some imperfections on them. And this is something that you will figure out as you go. But what I wanted to do was just start printing stuff to see what would happen. With some of those models, some people in the audience who already know 3D printing would probably look at that and go, no, you're doing that wrong, or no, that's not going to work. But sometimes you have to try and print something off and just see what the printer does to really see what's going to happen. Certainly there are a few where I threw a completely impossible task at the printer just to see what would happen. One such example was the Fluttershy model, where I initially tried to print it with no support at all just to see what would happen, and it very quickly just started making just a twisted mess on the print bed. So as soon as I saw that happening, I was like, okay, just stop, just stop. Okay, we'll put some supports on it. So I encourage you to experiment and see what happens, and you'll very quickly learn why things are done a certain way and what effect different things have. The Ender 5 S1 itself seems to be a really great starting platform. It's not the cheapest one out there. Creality also make the smaller Ender series, like the Ender 3, which is an incredibly popular model. There's loads of documentation and modifications available for it. But what I seem to have gathered is that a lot of 3D printer owners very quickly get into modding their printers. And the Ender 5 S1 seems to be a printer that out of the box has a very well-rounded set of equipment attached to it. It's got a great extruder that can handle high temperatures, allowing you to do more advanced materials like ABS as well as PLA. And it also has a very decent extruder that is built into the head and gives a lot of control. The polycarbonate build plate, I think, is probably going to be a personal preference thing. As I say, things stick to it quite a lot, and it's up to you whether that's useful or not. It does mean that it requires almost no preparation, but you also need to pull the mat off and then start bending the mat and scraping things off of it afterwards. It's difficult to clean, but as I say, it does require no preparation at all. I've seen some people who spray their mats with an adhesive first. I didn't have to do any of that myself. The actual user interfaces for the printer is very easy to work with. The printer's built-in interface was very straightforward and self-explanatory, and the Sonic Pad using the Clipper software is also very straightforward. The Clipper interface is more or less the same for whether you're running Clipper standalone or on the Sonic Pad, which means using the Sonic Pad, you can more or less find support for Clipper that will apply to the Sonic Pad. So you're not using some kind of specialist interface that no one understands. I think the Sonic Pad itself is fairly overkill for a starter such as myself. I think it's more applied for someone who's already very seasoned with a 3D printer and is getting into the more advanced stuff. I haven't gotten to the level where I'm starting to dial in that G sensor for faster prints yet, but I'm definitely going to start investigating that very soon after this. I think if you were running more than one printer as well, the Sonic Pad would be a godsend because you could just queue up. For example, if you were, doing small scale production, if I wanted to make 10 of those GPU mounts, I could have 2 printers and set up the Sonic Pad controlling both and just start mass producing them one after the other. So that's very useful for someone who's actually doing small scale manufacturing. I'm looking forward to doing a lot more stuff with this 3D printer. I've got other projects that I've actually been having on hold while I wait for this 3D printer to arrive that are going to now progress. So you'll be seeing more of the Ender 5 in my future videos. I want to give a big thanks to Creality for sending me the Ender 5 S1 as well as the Sonic Pad. The Ender platform as a whole seems to be very well documented, whether it's stock or modified, and there's a huge ecosystem surrounding them already, so you'll find loads of support for them too. There'll be links in the description down below to the Ender series as well as the Sonic Pad if you're interested in picking one up, and otherwise I'll see you soon in the next video. Thanks a lot everyone, bye for now.